Okay guys, what we're going to look at today is the function y equals ax² plus c. Now you'll notice this is a little bit different from your book. Your book has a b instead of a c. The reason I'm going to tell you it's a c is because that's what's going to be useful later. Okay, because quadratic functions, which is what we're looking at here, actually has a different general formula, and I don't want you to learn it one way with one letter and then need to change it later. Okay, so we're looking at y equals ax² plus c. What I want to start by doing is just graphing this so we can have a look and see what we get. Okay, so let's make a little table. Might be able to do this nicely. Oops. Make a table. Looks like this. All right, in my table, I'm going to have x and y, and we're going to have 0, 1, 2, 3, 4, and -1, -2, -3, -4. Okay, so we're going to start just by graphing y equals x². Okay, that's the first one we're going to look at. All right, so let's plug in values of x and see what we get. So if we plug in 0, y equals 0 squared, and that's just 0. If we plug in 1, y equals 1 squared, we get 1. If we substitute in 2, y equals 2 squared, 2 squared is 4, 3 squared is 9, 4 squared is 16. Okay, doing the reverse of that. So if we go down into the negative numbers, y equals -1 squared. -1 times -1 is 1. -2 squared is 4. -3 squared is 9. And 16. Okay, we're going to graph this. Now in this case, you can see that all our numbers are positive. So when I make my axes, I'm only going to look at the positive part. I'm going to do this over here on the right. So this is going to be my x-axis, my y-axis, oops, is going like this. This is my y. Okay, so we have x, we have y. Let's say that this is 20. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, that's fantastic. Let's instead make this top one can be 20. Okay, so 20. Here we have 10. Here we have 15. Here we have 5. Okay, 0 down here. All right, we're going to go 1, 2, 3, 4. Okay, and -1, -2, -3, and -4. Okay, so if we graph this, our first point is 0, 0. So we get a nice little spot here. All right, 1, 1. Okay, that's pretty easy. So we're looking at about here. -1, 1, fine. Okay, 2, 4. So that's about here. All right, 3 is 9. So we're going to put that roughly here. And 4 is 16. So here. All right, on the other side we have the same thing. So -2 is 4, -3 is 9, and -4 is 16. And what you can see here is this is no longer a straight line. Everything you've done until now has been a straight line. This one, however, is not. This is a lovely curve which looks something like this. Okay. And this is something that we call a parabola. Okay, so this is a parabola, and the equation we are looking at is what we call a quadratic function. So a quadratic function or equation contains x with the highest power of 2. Okay, so that means we've got x squared. Okay, we can also have an x, but the highest power of x is going to be 2. All right, now when we graph a quadratic equation, we get this lovely shape, and we call that a parabola. So a graph of a quadratic gives us a parabola. Okay, now just like with straight lines, these values actually tell us something. So in a straight line, we had y equals ax plus b. This is what we had for a straight line. Okay, you can see there's similar things going on here. We've got ax squared plus c. Okay, now in reality, the formula, the general formula for a quadratic equation is actually y equals ax squared plus bx plus c, but we're going to look at it with the b in it later. Okay, we're not going to get to that at the moment. All right, so the b for now, we're just going to pretend that that's not there. Okay, we're going to look at it later. All right, so we're only looking at ax squared plus c. Now the main thing we want you to get out of it today is what the a means. Okay, so the a in this parabola, in a straight line, it told us about the slope. Okay, now in a parabola, it tells us something similar. It tells us about how steep the arms are. All right, it tells us about the shape of the parabola. So what we want you guys to get out of this today is that if you have an a, if a is positive, okay, this is positive. A is greater than 0. This is positive. Now, if you think about people who are positive, positive people are happy, and happy people smile. Okay, and we actually get a parabola that smiles. Okay, so this is what we call a smiley face parabola. I like to call it a happy parabola. If a is less than 0, then a is negative, and this is a negative parabola. Okay, negative parabolas, negative people are sad. Okay, and sad people frown. So we get a parabola that's upside down. So we have happy parabolas and sad parabolas, and that's what we want you to get out of today's lesson. So whether a is positive and a happy parabola, so it's facing up, or if a is negative, we get a sad parabola, so it's frowning, it's facing down. Okay, so that's one of the things you can do today, just identifying whether we have a happy or a sad parabola. Okay, the other thing we can look at is whether a point is on the line. So if we have, so given y equals 2x squared minus 3 is point A, 2 comma 4 on the line. Okay, you guys have done this plenty of times with straight lines, but now we're going to do it with parabolas. Okay, so is this point on the line? You should know now that we have here an x and a y. Okay, and in our formula, conveniently, we also have an x and a y. So what we're going to do is put the x in place of the x. We're going to substitute x in for x, and we're going to substitute y in for y. Okay, so starting with the y, we have 4 is equal to 2 times x squared. X is 2, so 2 squared minus 3. And you'll notice I put it in brackets there. That's really important, especially when you're working with negatives. So get used to that, okay, because we're going to do it a lot in the future. So 4 is equal to, next step in BIMDAS is your indices, and we have here 2 squared, which is 4. So 2 times 4 minus 3. 4 is equal to, 2 times 4 is 8 minus 3, and 4 is equal to 5. And you can see that even though I could already see that this wasn't going to be correct, I still finished it off. It's really important that you actually finish your steps to show everything, okay? Don't just stop halfway and go, oh, I already know the answer. You guys know I don't care about the answer, I care about how you get there. Now we know that 4 is not equal to 5, so we're going to put not equal to through the equal sign here. So now it says 4 is not equal to 5, and then we need to make our final statement. So therefore, point A is not on the line. Okay, this is what I expect you guys to be able to do. If you don't show all these steps and you don't write a conclusion, then you don't get the points. So please make sure you're learning to do this properly. Okay, the other thing that we can do with this is we can calculate the missing coordinate. So for example, using the same formula, the x coordinate of point B is 12. Well, let's make it minus 12. What is y? Okay, so let's find the y coordinate. Now we know our formula, so we had y is equal to 2x² minus 3. All right, and we've been given x. We know that x is minus 12. So we're going to just substitute that in. So y equals 2 times minus 12 squared minus 3. So 2 times minus 12 squared is 144 minus 3. So we get 288 minus 3, which is 285. Okay, and that's it. So y is 285, and we're done. Okay, so that's how we find the y coordinate if we know the x. Okay, you guys haven't really got the skills yet to calculate the x coordinate. We will do that a bit later on. Okay, so that's the main thing we want you to get at the moment. We will talk a little bit more later about what else you can do with this.